Hi everyone, I am Mohammad Kazmi and my project is about predicting diabetes using K-nearest neighbor classifier. According to World Health Organization, 422 million people in the world and 29 million people in the US are suffering from diabetes. Diabetes is common in adults and it develops a higher risk of heart disease, kidney damage, brain stroke, and vision loss. The aim of my project is to enable optimized and effective treatment procedures for diabetes diagnosis. Early detection of diabetes cuts down costly treatments significantly. The following research used the Pima Indians diabetes dataset to predict diabetes based on blood glucose, diabetes pedigree function, age, and BMI. They normalized the dataset using min-max normalization and evaluated their model on decision tree and naive Bayes algorithm. The accuracies were 76.9 and 79.5% respectively. I used the Pima Indians diabetes dataset which belongs to the National Institute of Diabetes and Digestive Diseases. For my project, diabetes is determined based on blood glucose, blood pressure, BMI, and age. Originally, the dataset consists of 768 patient records. I used only 100 records to evaluate my model. My model takes as input the blood glucose, blood pressure, BMI, and age values to generate a binary classified output where 0 means non-diabetic and 1 means diabetic. I performed an exploratory data analysis of the dataset and found that there are 58 non-diabetic and 42 diabetic outcomes. Here, this table shows the first few instances of the dataset. I split the data into 80% training and 20% testing. The code for my project works on Google Colab and its implementation and it's implemented in Python. I use the scikit library to import the KNN classifier, reduce the attributes and instances from my dataset, and generated the statistical description of data as well as performed exploratory data analysis to gain an insight about the data. I replaced the missing and noisy values in the attributes with the mean of that attribute. In addition, I use z-score normalization which transforms the data in a way that it has the mean of 0 and a standard deviation of 1. Normalization helps in developing an accurate and precise model. I chose the k-nearest classifier to evaluate my model. KNN works by selecting the k number of neighbors nearest to the test data in the multi-dimensional feature space. I compared the accuracy of the model against a range of k values to choose the optimal k value and achieved an optimal k value of 7. My findings provided significantly optimal results. I achieved an MSC value of 0.1 which is good as it is close to 0. My model achieved an accuracy of 90% indicating that the model mostly accurately predicts the correct outcome. My model's F1 score was 92% for non-diabetic outcomes and 86% for diabetic outcomes, which indicates a good overall performance. In addition, I constructed a confusion matrix which shows that my model efficiently reduces the number of false positive and false negative outcomes as there is only one false positive and false negative result. I performed a five-fold cross-validation and achieved an average score of 76%, which may be related to presence of outliers in my dataset. My model is computationally efficient with a runtime of 5.2 seconds. Here is a comparison of my model with other research works and machine learning algorithms. From these results, I inferred that KNN outperforms other ML algorithms for diabetes prediction as it has a higher accuracy. Future improvements of my model include identifying and removing outliers by plotting box plots, increasing the number of instances on the diabetes dataset, and reducing randomness observed in cross-validation. In the future, I want to implement my model on different datasets from different medical organizations, and I want to test the same Pima Indians diabetes dataset on advanced ML algorithms such as naive Bayes, decision tree, XGBoost, logistic regression, and neural net. Thank you.